I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about a rapid way that you can fine-tune a YouTube anti-roll tank for a ship design. So for this example, we're going to use the generic offshore supply vessel. And if we just look at a picture of it here, this is in the heavy ship condition. And you can see it does have bilge keels here, but what we're going to do is just play with a YouTube anti-roll tank and see what we can do to kind of like really fine-tune it to the roll natural period for this ship. So why this is significant is you may come across one of our blog articles on how to tailor an anti-roll YouTube tank for design for a ship. And like one of the biggest things about inertial-based anti-roll devices like anti-roll slosh tanks or anti-roll YouTube tanks is like you always need more water, you need more inertial mass than you think. So, you know, these kinds of systems, you need 2, 3, 4% of displacement mass. You need a lot of water. Now, if you sort of start this constraint with like get as wide of a tank as you possibly can, get as wide a reservoir tanks as you possibly can, and then eventually add as much length as you can like into the screen here, it's going to give you a lot of water mass. And what the idea I wanted to kind of highlight here is to fine tune it. If you have a dynamic model of the YouTube tank, you can fine tune it pretty easily by adjusting, given these other constraints in place, the duct height. So when you think about it, we got these big reservoirs and there's a lot of water in there. The duct is kind of the limiting factor for how fast the water can go from one reservoir to the other reservoir. And generally speaking, if you want the water to move faster, you want it to line up to be faster to reach the roll natural period of the vessel, then you make the duct height bigger. That gets more water flowing one side to the other side. And if you want to have it slower, then you decrease the duct height. So we can do that rapidly in the ProteusDS ShipMo3D toolset and fine tune that kind of tank property. I want to show how to do that. So first, I want to show in Seakeep Regular, we have the regular model of the ship that has got bilge keels, but it doesn't have a YouTube tank. If we look at the motion RAO here in beam C conditions at 0 speed, we've got a peak roll RAO of like 4.1, 4.2. So, you know, just getting an idea where that is, and it's around like 0.59, you know, basically 0.59, 0.6 radians per second. So what I've done is I've made an alternative version of the build ship configuration here with the YouTube tank. And the parameters for the YouTube tank like match the little image that we've got here, right? So length is like into the screen kind of thing. Duct width, that's this parameter here, spacing between these two. And then the reservoir size is 3 meters. So the beam, maximum beam of the generic offshore supply vessel is like 15 meters. So we have 3 plus 8 plus 3, like we're starting to get to be like close to maximum beam here. Like I don't think we can really get more beam out of this width of the thing at 14 meters. And let's just say like we can't get more than 3 meters out of this, right? So given these kind of constraints, like how can you quickly, if you have software like this, how can you fine tune it? Well, we play with the duct height here, right? And of course we have like the fill level and stuff like that, but the duct height has a really strong influence on that. So we run our configuration here, and then we'll make sure we're loading the YouTube tank model, the ship model with the YouTube tank in it, and we'll run the Seakeep Regular to generate the motion RAOs. And what we're doing here is we're looking at the tank response, and we're going to look at the ship response to see how well these are lining up. So now we see the roll RAO is still pretty peaky. It's starting to look a bit weird. And what's happening here is the peak's gone down a little bit to 3.9, but like it's not really that strongly affected. And then you can see this new field showing up here, the YouTube tank response. So it's got a double peak here, but like really it's because it's too far off the roll natural period. That's what's happening. So yeah, we have a peak here, but really what you want to do is kind of look in the middle of the area of this kind of curve. So this is like 0.55, right, instead of like 0.59. So we want to go faster, higher frequency. How do we make it faster? Well, we make it faster by making the duct height a little higher, right? So go back to build ship, and we'll go say 0.6. I'm just picking a bigger number. So we run this again to assemble the updated model. Now it's loading the same file. I just overwrote it. I'm just trying to do this quickly here. So we'll run the RAO calculation again. And if we look at the RAO in beam C 90 degrees, okay, the roll RAO is starting to look a little bit better. Like this is lining up a little bit better. It's still not quite in the middle. Ideally, we want the to have sort of equal two little peaks on either side. But even still, the maximum roll RAO has gone down to 3. You know, I think if we just make it a little bit faster, a little bit higher, we want this to move over just a little bit more. It'll squish that peak down, and this one will go up a little bit. So let's just go like edit YouTube tank here, make it just a tiny bit higher, 0.65, just a little bit faster, run it again. And then we go to seakeep regular and run the RAO analysis. So now it's got just that 0.65 duct height. Plot the motion RAO here. And there, okay, that looks nice. We've got sort of even sized peaks on either side here. Now at that same kind of original natural period, it's gone down to 2. So 2 from 4, that's a like 50% reduction. That's pretty good. It is a little bit higher on either side here. And then the YouTube, but you know, that's what it's like with this kind of system. The YouTube tank frequency here is looking like pretty well lined up. So anyway, the main point that I wanted to show was just get this idea of like, if you can get as big a tank in place as you can kind of fit in the ship, a quick way to tune it is playing with that duct height. Faster to make it taller, slower to line it up to the natural roll period. Make the duct smaller, right? Yeah, and that's all for now. Thanks for watching.